I'm here today on our construction project in East Texas on the north shore of the Sam Rayburn Reservoir. I'm going to show you how we avoid foundation failures. This is part 2 of the design and construction of your foundation. I'm Mike with Robert, my superintendent, for this design build house project. In my last video, I discussed how to avoid costly foundation problems. In this video, I'll discuss the procedures in designing and building a proper foundation that will avoid these costly repairs. So let's get started. In our last video, we discussed how the Geotechnical Soils report for this project was performed and used by the structural engineer to design a foundation for these existing soil conditions. You see our foundation design here. Our structural engineer shows a post-tension slab with 3,500 psi concrete. And we're to remove, according to his notes, 3 foot of unsuitable soil and replace it with 4 foot of select structural fill. He indicates the plastic index number for this structural fill is to be between 6 and 14. And the fill is to be placed in 6-inch lifts and compacted to 95% of the dry maximum density to 5 foot outside the building line. On our projects, we use a checklist, so looking at it here, you want to make sure you have your building surveyed and have your survey crew show the outline of the building with the additional 5 foot extension. And according to item number 2, you want to have benchmarks established. In our case, the structural engineer wanted us to be 1 foot above the existing highest elevation on the lot. As you see here, we've identified the red X as the elevation point, and then we set a benchmark elevation on the nearest power pole at 1 foot above the grade. Then our excavating contractor would use this benchmark while excavating and backfilling the house and the garage. In item number 7, you want to make sure that either you, your general contractor, or your excavating contractor have identified any underground utilities in the area of your excavation work. In some places, all you need to do is call a 1-800 number or your Miss Utility phone number or some public utility company, and then they'll send out a survey crew to identify any underground utilities. They'll stake the utility lines, and you want to avoid these utilities during your excavation work. So a quick summary before excavation begins: you want to locate all underground utility lines, and 2, you want to establish the benchmark elevation for your excavating depths, and 3, you want to survey and stake out your building. And then when we begin to excavate, as in compliance with number 8, we want to verify the stripping of the site, the preservation and depth removal of the topsoil, and the location of a stockpile of the topsoil to an area away from the excavation so that you can use the topsoil at the end of the project to spread around your house and your garage. Item number 9, you want to verify that drainage is provided continuously as excavation progresses. Now, we were fortunate in having no rain during our excavation and backfill operation, so our project went pretty smoothly. Item number 10, you want to verify the source and type of the imported structural fill that your excavating contractor will bring in. As noted, you want to verify samples are tested and approved. We had our geotechnical laboratory acquire a sample of our excavator's structural fill material. They analyzed it back in their laboratory to confirm the specified characteristics of our backfill material and that it meets the structural engineer's specification. The laboratory conducts a proctor test of the sample to determine the maximum dry density and the optimal moisture content. And per item 11, we want to verify the testing, the inspection, and compaction are performed during the excavation and filling process. You see here we have our geotechnical company technician. He conducts compaction density tests. He uses a nuclear soil density gauge. The nuclear gauge will have the maximum dry density or Proctor number in pounds per cubic foot and the optimal moisture content of the backfill material inputted from the laboratory. But before the technician starts, you want to review with him a testing plan for the area being backfilled. As you see here, these are different spots that he will test the density compaction to see if the excavating contractor has compacted the fill material to the required specification. These are numbered spots that he'll transpose on a logbook, which then will be used by the laboratory to give us a report of the compaction density testing. And you see here he'll pound a metal pin 6 inches into the ground. And then he'll pull it out and insert the nuclear gauge rod into the soil and press start. The gauge is nuclear, so it's lined with a lead shield around the radiation source. And he wants to be safety conscious as he starts to test. So he backs away from it as it emits the radiation into compacted fill. With the test complete, the gauge will read out the in-place dry density value, and this value number is compared to the maximum dry density that was determined in the laboratory and is expressed in the form of a percentage. You see him checking the number right now. And this percentage number should be in compliance with the structural engineer's specification, where he indicates that the compaction should be 95% of the maximum dry density, or the Proctor. He logs the results in, and the geotechnical firm produces a report showing the results. And as you see, the spot areas that were tested, they were passed with the required 95% of the Proctor density. Item 12, you want to verify compaction is performed in lifts as required. And according to the structural engineer, the select fill is to be placed in 6-inch lifts. And the excavator uses a laser level along with the benchmark at the power pole to place the fill at the required depth. You then continue to conduct these compaction density tests on the lifts as they are placed. And if he conducts a test and it fails, then the excavator needs to recompact that area, and then you test it again. And here's our final lift being compacted into place. And if you follow the steps that I've shown you here, it'll help you avoid the foundation failures that are prevalent in the state of Texas. So we wish you success on your upcoming project. Thank you.
Certainly. If at first you don't succeed, keep on sucking till you do succeed.